Hi, how's it going? I'm Lindsay, and this is Lab 2 on line charge. So the objective of this lab was to substitute our previous experiment with point charge assumptions with a line of charge assumption, and to determine the electron deficiency on one piece of tape. And lab 1 charge magnitude was 2.236 times 10 to the minus 8th coulombs approximately. We're also assuming that the charge above was calculated accurately to proceed with this experiment. And by using a line of charge equation instead of a point charge, the overall distributed charge should be more precise. And a key finding was that the estimated magnitude of Q to make the bottom tape float in the line charge model was 2.383 times 10 to the negative 8th coulombs. So the materials and procedures were the same because we're reusing our lab 1 data, the materials being the tape measure, clear tape, flat surface, 2 books, and a recording device. And we stuck together the 2 pieces of tape, rubbed them. We fixed one of them between 2 books and slowly lowered the other tape until the tape attached to the book started levitating. And we measured the distance between the 2 tapes before and after levitation to use in our calculations. So some important physics concepts to understand, first of all, is the electric field equation on the upper left. And then we have the force of gravity magnitude equation. And to put it in vector form, it would just be in the negative y-hat direction. As far as line of charge goes, to calculate line of charge, you take the total charge Q and you treat it as being uniformly spread along the tape, and you're defining a linear charge density lambda equals Q over L, and then you compute the electric force by summing or integrating the Coulomb force contributions for many of the tiny charge elements along the tape. And farther elements therefore contribute less force, and so I predict that the net electric force is going to be weaker than in our point charge prediction. So our system is tape A and B, and our surroundings is everything else, which can allow us to set the gravity force and electric force equal because net force would be 0. And our assumption is that there's no air resistance and that each tape created has the same magnitude of charge that's distributed evenly throughout. So here are the measurements that we collected, same as the first lab. And here is my new glow script model with the line of charge model. The green arrows represent the electric field vectors. The white arrow is the net electric force on the tape. The bottom tape and the yellow arrow is the gravitational force. The top tape we're defining as negative and the bottom tape is positive, which means that the electric field at the bottom of the tape points towards the negative top tape. And since the top tape is above, the green arrows point upward. And just here's a little bit of my code. I have my physical constants, which are the same from the first lab, my observed values, as well as my electric field function. And then I also have my code for calculating line of charge, as well as the field and the force on the bottom tape due to the top tape. So here is the calculations that my second model predicted, and my glow script code is beneath. One key thing I do want to point out is that the magnitudes of the gravitational force and the electric force are not exactly equal in this calculation, and I want to discuss why this is, because in theory they should be equal, but the balance in my model is idealized, or the model itself is not idealized, but the balance that the net forces are 0 is idealized. And this may be the difference may be due to the fact that the tape might not be in a perfect static equilibrium. It might be oscillating when I took the measurement. The model approximation also could introduce error, for example, from things like assuming that there's uniform charge distribution along the tape, and also we're neglecting additional forces like air resistance. So for some questions I wanted to answer, the first question was asking about the differences between the estimated magnitude of Q in the point charge model and as well of the magnitude of Q in the line charge model. And they both are 10 to the negative 8th, but they are slightly different. And the magnitude in the line charge model is slightly bigger, which is what I predicted in the beginning. And why do these estimates differ? Which value is more likely to be closer to the real value and why. So with the point charge model, the concentration is the charge is all in one location, which makes the effective separation smaller and the electric force stronger. So it predicts a slightly smaller Q. And the line charge model spreads charge across the tape, which reduces the net force and requires a larger Q to match the same experimental condition. And the line charge model is more realistic for, at least for macroscopic objects, because the tape's charge is distributed along its length, and that better matches physical reality than the point charge model. Thank you so much.